Imagine the dead of night in Rostov Oblast, Russia, where the quiet hum of distant engines suddenly shatters into a symphony of terror. At 1:47 a.m., 6 sleek Ukrainian UJ-26 Beaver drones slice through the darkness at a mere 150 feet above ground, their wings whispering promises of retribution. They zero in on the Salsk railway station, a vital artery pumping military fuel and ammunition toward the Ukrainian front lines. In an instant, the lead drone dives, its payload erupting in a blinding flash that ignites a fuel-laden train car. Flames leap 200 meters high, devouring tankers in a roaring inferno, as secondary explosions ripple through the night like thunderclaps from hell. Shrapnel shreds overhead power lines, plunging the station into blackout chaos. Civilians scramble from passenger cars, their screams drowned by the crackle of burning metal, while Russian responders race against a wall of fire that's already claimed one life and stranded thousands. This isn't just a strike, it's a calculated gut punch to Russia's war machine, proving once again that the skies belong to you, Ukraine. If that doesn't grab you, stick around, because we're diving deep into this game changer. Hello everyone, welcome back to the Strike Point Media channel, where we break down the raw power and strategy of modern warfare like no one else. If you're as hooked on these high-stakes drone ops as we are, smash that subscribe button right now and drop a like on this video. It helps us bring you more explosive breakdowns just like this one. Today, we're dissecting the Ukrainian drone strike on the Russian train station in Salsk, Rostov Oblast, that turned a quiet rail hub into a blazing symbol of resistance. From the thunderous exterior assault to the inner workings of these marvels of engineering, we'll cover every angle: the brutal performance under fire, ironclad safety features that keep pilots worlds away, stand out unique selling points that make these drones unbeatable, a no BS look at the price tag, and wrap it all up with what this means for the front lines. Let's roll. The exterior of these Ukrainian UJ-26 Beaver drones is a masterclass in stealth and menace, designed to slip through enemy skies like ghosts in the machine. Picture a sleek, aerodynamic frame stretching about 3.5 meters in wingspan, crafted from lightweight composite materials that blend radar, absorbing coatings with a matte black finish to minimize visual and electronic signatures. The body is a tapered fuselage, narrow and elongated like a predator bird in flight, with fixed wings that boast a high aspect ratio for exceptional glide efficiency. Think 12:1 or better, allowing unpowered loitering for hours after fuel depletion. At the nose, a bulbous sensor pod houses electro-optical and infrared cameras, giving it eagle-eyed targeting capabilities even in pitch-black conditions like that fateful Salsk night. Twin vertical stabilizers at the tail ensure stability during high-speed dives, while the underbelly cradles a modular payload bay that can swap warheads in under an hour. From 5-10 kg high-explosive fragmentation bombs for precision hits on locomotives, to thermobaric charges that superheat the air and turn fuel trains into instant fireballs, the landing gear, retractable skids for rough field launches from hidden Ukrainian farmsteads, folding away to reduce drag once airborne. Propelled by a rear-mounted electric ducted fan or small piston engine, whisper quiet at under 60 decibels, these drones hug terrain at 150 feet, evading radar with GPS, jamming resistance built into the composite skin. In the Salsk strike, this exterior design shone. The drone's lower, observable profile let them evade initial Russian air defenses, closing to within 500 meters before unleashing hell. Scorch marks from near misses show the heat-resistant ablative coatings holding firm, while the reinforced leading edges shrugged off bird strikes mid-mission. It's not flashy, no glowing LED or chrome accents, but pure utilitarian lethality, weighing in at just 25 kg empty, making it portable by a single operator. Compared to bulkier Russian Orlan 10s, the Beaver's exterior screams efficiency, slimmer profile for tighter formation flying, as seen in that 6 drone swarm that synchronized their attack to overload station defenses. Wind tunnel testing in Ukrainian labs refined those winglets for 20% better lift in crosswinds, crucial for Rostov's gusty steppes. Up close, you'd notice the modular antenna array on the dorsal spine, tunable for satellite uplinks that beam live feeds back to command centers 400 km away. This isn't just a shell, it's a canvas of calculated destruction, where every curve and seam contributes to outmaneuvering SAM systems like the Panzer S1 that failed spectacularly here, the paint job. IR suppressing nanocoatings that fool thermal seekers, ensuring the drone remains a cold shadow until impact. In essence, the exterior embodies Ukraine's ingenuity, turning scavenged parts into a silhouette that haunts Russian logistics nightmares. Shifting gears to the interior, where the real wizardry unfolds, the UJ-26 Beaver's guts are a labyrinth of cutting-edge avionics and ruggedized components packed into a deceptively compact 2-meter fuselage core, making it one of the most densely integrated UAV in asymmetric warfare today. At the heart lies a custom flight control computer, a hardened ARM-based processor running real-time Linux kernel with failover redundancies, triple gyroscopes and accelerometers cross-check data every 10 milliseconds to correct for turbulence or electronic warfare pulses, ensuring pinpoint accuracy even when jammed by Russian Krasukha 4 systems. Memory 16 GB solid state drive for onboard mission planning, storing topographic maps of Rostov's rail network downloaded pre-flight, allowing autonomous waypoint navigation via INS/GPS fusion that degrades gracefully to dead reckoning if signals drop. The power plant interior is a marvel, a brushless DC motor spinning at 50,000 RPM, fed by swappable lithium polymer batteries totaling 10 kWh capacity, with thermal management via phase change material heat sinks that keep temps under 60 degrees C during 4-hour loiter phases. Fuel for extended range, an optional 5-liter bladder of JP8 compatible kerosene injected via piezoelectric valves for ultra-efficient combustion yielding 200 km range at 120 km/h cruise. Sensor suite dominates the forward bay, a 1080p day/night camera with 30x optical zoom and laser rangefinder, wired to an NVIDIA Jetson Edge AI processor that runs YOLOv 8 object detection, trained on thousands of images of Russian T-90 tanks and RPO fuel cars, to identify and prioritize targets like the Salsk locomotive, flanking it, synthetic aperture radar SIR panels, compact gallium nitride arrays scanning 5 km ahead for moving trains, even through smoke from prior strikes, communication backbone. A software-defined radio SDR module supporting encrypted COB, and data links up to 300 km line of sight with mesh networking for swarm ops, each beaver pinging the others to share threat data, as in the coordinated Salsk salvo, where one drone's evasion maneuver fed corrections to the pack. Payload integration is seamless. The bomb bay features electromechanical release servos synced to GPS timestamps, with inertial safing to prevent duds on soft impacts. Human interfaces, a rugged tablet ground station app coded in Python with Teak Hinter GUI, lets operators script attack profiles, circle loiter over Salsk at 200 m, dive on thermal bloom from idling engines, cooling. Passive vapor chambers wick heat from the CPU to outer skins, while EMI shielding, metal foil wraps, blocks Russian EW spoofs, structural integrity inside, carbon, fiber longerons laced with aramid fibers absorb 50G shocks from evasive rolls, tested in drop simulations mimicking AA gunfire. Wiring harnesses use a male-spec Teflon, insulated bundles, color, coded for quick field repairs with Obi-Diroman 2-style diagnostics port for post-mission teardown. Autonomy shines in the neural network core, a lightweight TensorFlow light model predicting wind shear from altimeter feeds, adjusting flaps in real time, vital for that low-altitude ingress over Rostov plains. Backup systems abound, secondary ESC for motor control, capacitor banks for emergency 30-second bursts to evade locks, and a destruct sequence triggered by IFF failure to deny tech to captors. Software-wise, it's fortified with SE Linux policies against hacks, with over-the-air updates via blockchain, secured keys from Kiev Labs, the cockpit equivalent. A virtual one in the GCS software, rendering 3D station models from OpenStreetMap data, overlaid with live IR feeds. Operators watch the Salsk fire bloom in augmented reality. Ergonomics for maintainers. Modular bays snap apart with quarter-turn fasteners, exposing the belly for warhead swaps in under 5 minutes. Vibration isolation mounts cradle the avionics stack, damping engine thrum to protect gyros. Power distribution. DC-DC converters step down to 5V/3, 3V rails for peripherals, with surge protectors against EMP-like pulses from nearby detonations. In a nod to sustainability, recyclable composites minimize waste, while firmware includes eco modes throttling power for training flights. This interior isn't just circuitry, it's a symphony of silicon and steel, where every wire and chip pulses with the resolve to turn the tide. Expanding further, consider the data fusion layer. Kalman filters blend IMU, GPS, and baro, altimeter inputs for sub-meter positioning, crucial when skimming treetops to avoid spotters. The AI edge extends to predictive maintenance, vibration sensors flag-bearing where pre-flight, averting mid-mission failures like those plaguing early Iranian shods, cybersecurity, intrusion detection via anomaly-based ML scans packet flows auto-severing compromised links. For the Salsk op, this meant flawless handoff, lead drone designates, followers prosecute, all synced via time, slotted Aloha protocol to dodge interference. Human factors engineering shines in the GCS ergonomics. Adjustable HUD reduce operator fatigue during sick, sour vigils. Materials science inside. Kevlar bladders for fuel self. Sealing against punctures, while conformal coatings guard boards from Volgograd's humid summers. The upgradability. GPO pins for future payloads, like EW jammers or decoy flares. In total, this interior packs the punch of a manned fighter into a back-sized beast, embodying Ukraine's scrappy innovation, bootstrapped from commercial off-shelf parts into a force multiplier that rewrote the Salsk night. Performance-wise, the UJ-26 Beaver doesn't just fly. It dominates, clocking cruise speeds of 120-150 km/h with a max dash of 200 km/h for terminal attacks, as evidenced by the blistering descent that torched the Salsk fuel train in seconds. Endurance is its ace, up to 6 hours on internal fuel, extendable to 10 with drop tanks, covering 400 km radius, plenty to reach deep into Rostov from launch sites near Kharkiv, maneuverability, agile as a sparrow, pulling 4G turns with ailerons and split rudders, ideal for dodging manpad's flares during egress. Payload delivery is surgical, CP under 3 meters via INS-corrected GPS with video confirmation before release, minimizing collateral while maximizing pain on that locomotive hit. In swarm mode, like the 6-unit Salsk pack, they achieve distributed autonomy. Leaderless consensus algorithms allocate targets, boosting hit rate to 90% against defended sites. Environmental resilience. Rated for -20 degrees C to +50 degrees C ops, with de-icing heaters on wings for Black Sea fog, and IP67 seals shrugging off rain during field assembly. Reliability stats from Ukrainian GWAR logs show 95% mission success, far outpacing Russian Lance. It's 70% due to superior vibration isolation. Fuel efficiency, 0. 5 liters per hour cruise thanks to variable pitch props optimizing thrust vectoring. Under load, it hauls 15 kg ordnance without trim loss, maintaining 500 ft/min climb. Real world proof in Salsk, despite EW jamming, it held link for 28 minutes, streaming 720p feeds at 2 Mbps. Scalability. Production ramps to 50 units/month, with field mods for anti-drone nets via net gun payloads. It's not invincible, vulnerable to dedicated EW, but performance edges make it a logistics killer. Safety features elevate the Beaver from tool to guardian, prioritizing operator and asset protection in hostile skies. Primary is the one-way data link. Encrypted frequency. Hopping SDR prevents hijacks with auto-destruct if spoofed signals detected. Salsk drones vaporized on command to deny wreckage. Collision avoidance. TCAS. Like system using ADS-B sniffers and AI vision, alerting to Russian Mi-8s or wires. For ground crews, inert warhead safing via arming pins and RF locks, plus blast, deflecting launch rails. Flight envelope protection, software geofences enforce no-fly zones, auto-arc, on low fuel or link loss, landing via parachute if needed, EMP hardening, Faraday caged avionics survive 50 kV/m pulses, operator safety. GCS with biometric locks and redundant servers, ensuring only cleared users command. In testing, it endured 20 mm proxy fire without cascading failures. These layers kept Salsk pilots unscathed 400 km away. Unique selling points set the Beaver apart. It's the affordable asymmetric edge-launchable from pickup trucks, no airstrip needed, unlike Russia's lumbering Orlans. Swarm intelligence via ROS-2 framework enables emergent tactics, like feints drawing fire while killers strike. Modular bays swap sensors for elite missions, turning it into a SIGINT spy. Open source flight stack invites global tinkerers, fostering a drone ecosystem. Eco, footprint, low emissions, recyclable airframe. For Ukraine, its homegrown pride 95% domestic parts, defying sanctions. In Salsk, USB Sean, silent ingress, pinpoint hits, 0 losses. Price breaks it down affordably at $15,000-20,000 per unit. It's a Steel versus $2M Reapers, mass producible with 3D printed mold. Payloads add $2K 5K, full swarm of 6, under $150K, vs. Russian equivalents at $50K plus. It's a bargain for disrupting billion-dollar logistics. In conclusion, the Salsk strike via UJ-26 Beavers isn't just a win, it's a blueprint for future wars. proving cheap, smart drones can hobble empires. Ukraine's resolve burns brighter than that station fire, signaling endless innovation ahead. What strike should we cover next? Comment below, subscribe for more, and like if this lit your fire. Stay vigilant out.